Hi everyone, how are you? Good. Okay, so let's talk a little bit about some challenges that we were having with Jupiter. um, I wanted to address that first before we move forward with the next chapter. As I was receiving some email regarding Jupiter, some of you are successfully fulfilling all the tasks through Jupiter. There has been some changes in Jupiter, especially in the pointer and some of the other areas. So I had gone through and tested some of the programs and retest them. So some of the things that came up was that why isn't my program producing any output? Generally, because you have to reload the actual module for Python, so that way it will compile. Now, Jupiter has stopped, supporting some of the other areas regarding pointer, and some of the other things that didn't go through as far as the stdio on the C side. So as you do some of this in Jupiter, it might not be able to recognize it. And so when I look through it again, it's slightly different than what it was originally last year. So if you have any concern or any questions, if you have attempted and didn't get the right output that you needed, make sure that you communicate with me. But in general, I will go through the assignments and I will give you the proper feedback. And I wrote some of you regarding your questions regarding Jupiter. Okay. All right. So in this week, we are going to continue to set on our course for program performance improvement in Python. And we are going to proceed to the next chapter. So let me get to the screen share here. All right. So in this week, we are going to use a different package called Numba, and we are going to work with PyPy. And in this particular chapter, we're going to use a tool called Just-in-Time, and JIT compilers allow us to improve our program outcomes. So when you use JIT or Just-in-Time, I call this JIT, that allows the compiler to be able to use the decorator and its package to be able to give you a better performance. So one of the first package that we're going to use, and all today's assignment, you can use your IDE. Make sure that you bring in the package, and I'm using Tawny, so you can run this in Tawny. And if you're using Linux or just straight through Windows or VS Code, make sure that we have the proper package installed. Okay. So Numba is a library, and this allows us to compile functions in small chunks. This is also going to use C. And so if you want additional reference, you can look at the documentation that I include the link here. And when you write function in Python, what you can do is you can use Numba to translate that. So that way it would use LLVM compiler library, and it's going to compile things in C to be able to give you the output. Now, you don't really need to have additional extra things like Python, but you do need to bring in the package. And so with that, we would see that it would improve the speed through C. And we are going to place a decorator right above the function that we're going to use, like the example here. So after you install your Numba, you would then import it using the import statement, like the example. And then you would add the decorator. And since we name it JIT like this, we would decorate it like this. So you would use the add symbol, and you would put in the identifier that you had included in your import statement. Okay. Now the parameter here is we would put it true, so that way it would not run directly with the interpreter. So it would use Numba with its algorithm to use the LLVM, which is incorporated with the library. Then you would define your function, just like how you did in Python. And in this example, what we would do is we would generate random number, and then we would incorporate the conditions in our loop to check the value. If it exceeds, right, a certain limit, then it's going to increment. Okay. So this is a simple example that you can see and throughout today where we'll practice using the package and to write our functions. So just to give you a little bit of history, this is Numba actually came from the same author or the creator that wrote NumPy library, and it uses the runtime from the low-level virtual machine. So when you write the functions and you decorate your function using JIT like this from the Numba package, what it's going to do is it's going to break it down to the low level. So it's going to use the LLVM to be able to compile your function. And so therefore, we would see that the runtime is going to be improved. And there are additional details in how LLVM handle language and how C language compiler is able to give you the output that's expected. And so in the implementation of this, right, we want to look at how we would use Numba, especially in the area of computation that would relate to numerical. So for those of you who want to work with data analysis, things like that, this particular package is essential, or it could be of importance. And as we mentioned before, we can use special decorator for our functions. And so what that will do is it's going to broadcast. And in this case, we're also using NumPy. So when we do this, we can broadcast it and be able to apply it to the arrays that we would write with the NumPy. We would see this in today's assignment. So in this particular example, just like the last one, we do have a decorator. And when you see parallel like this, right, we want to be able to apply the algorithm from Numba to be able to process things in parallel. So that means that it's going to use your processor multi-core to be able to execute them concurrently, compared to what you've seen in a normal traditional Python program. It's going to execute one line at a time or interpret one line at a time. So in the case where you have complex function or functions that require a lot of processing, you would want to implement Numba, right, and use the decorator to be able to execute your function and improve its runtime. So you can implement this in a lot of the notebooks, or like Jupyter notebooks. So Jupyter is also able to support Numba. And again, right, when you're using IPython, similar to what you've seen in Python, there are particular process. So if you don't have the library installed locally, you have to bring that in. And especially for C compile library, you make sure that your computer system would have some form of C compiler. So if you're using Windows system, that would require the C++ package with its compiler. And then in the Linux side, you saw some of this when we did the lab, right? We would bring in the compiler for the GCC. And so you have to have all of those mechanical components in order for things to run. So this gives you some information on if you use interactive computing, or if you're using an interface like an online notebook like Jupyter, Sage, Colab, things like that, right? It would use Spark or Dask framework to be able to give you what you would see. But again, we would want to make sure that our library is available. So it does support your different architecture. So in the future, if you need to work with different processor, right, you can always go to their documentation. But currently, this is what you see. So your 32-bit AMD, right? Power 8 9, your ARM CPU. So those are like your smartphone CPU, Snapdragon, by Qualcomm, etc. Right? Like if the CPU support ARM, and that would be your assembly language, NVIDIA and AMD GPU, so graphic adapters. So your video cards or GPUs will work as well. And the later version of Python, so anything after 3.6 can be adapted. So currently we should be using 3.9 or 3.10 for Windows, Mac OS, and Linux. Okay. And I also included the link for your Numba guide. And so we can come here and we can see how we can get started. So it's always good to take a look. And so where did I get all the information? And they also update this. So as they implement this for additional processor, and in the case that you need to work with this, make sure that you check this part out. So the architecture is listed here, right? Like your Intel x86, Intel x86 64, so 32-bit and 64-bit, your ARM. And so in the case where if you're using, for example, Apple system that would use something different, then you would want to make sure that you check the processor requirement. Okay. Now, this is going to also be using NumPy, so we want to make sure that we do have the latest version, or at least 1.18 NumPy library with it, right? Because these two libraries work together. Now, if you're using Anaconda, again, we would use conda command to install, or if you don't use Anaconda, you would use the pip install, right? And in the case for most of you have different version, there's some of you that have different version of Python, make sure you use pip3 for Python 3. Okay, so those are some of the things that we need to look out for when we're doing the installation, right? The hardware and also the version of the Python we're using. Okay, and there's some example that you would see very similar to what we've seen in our textbook and our notes. And so you can always use the example and test the example in the case that you don't have your notes in your text. Any question? Okay. So you saw a little bit on how to do the installation. And so in this, I put down that we can use pip or pip3 to do the install. Now, installing on your computer, and if you're using IDE, you got to make sure that your IDE see the package. So you will likely need to install that through the IDE as well. Okay, so I will show you how I did that with Tani. All right, let's come back to your assignment here. For the first question, it asks you to describe the functionality of Numba. So Numba allows the system to translate Python functions to optimize machine code at runtime. And it's using the industry standard low-level virtual machine, your LLVM compiler library. And because of this, right, it's going to give us better performance. So as you go through the course, you would see that we would add in, right, different package and library. So you have options when you build your Python program in the future, whether it's for data analysis or applications or web application, you can integrate some of these libraries into your program and be able to improve the performance. So again, this allows us to translate the function, right, at the low level, so that way our performance is improved. For question number 2, it asks you, how can you install Numba library? And in general, right, we can use the pip command. So pip3 install Numba. In the case that you have Anaconda, you would use conda install Numba. And when you use Anaconda, the package is going to be placed in site packages inside Anaconda or Conda subdirectory. So making sure that you have the proper link for your system path originally. So if you use Conda, right, you got to make sure that Anaconda is linked properly. And if you do that, then everything works. If you don't use Anaconda, right, if your Python path is set properly, because it's going to point everything back to your site packages folder. And so as you install, it's going to place it there. And if it doesn't see your site packages folder inside Python version, right, it's going to get confused and not be able to build. So in the case where if you have many different versions or 2 different versions of Python installed, it's going to place it in one and not the other. But if the other is linked to your system path, it will not be able to see your package. And that tends to be the problem when we have issues with working with these packages. Okay. So for 1 and 2, we would have the answer there. Any questions regarding 1 and 2? Okay. So now let's take a look at the function that we need to define. So in normal Python program, right, you would define a function like this. So we would use the def keyword, give our function a name, and the parameters, whatever variable or container that we're trying to pass. So in this case, we have a sumSQ function. And we initialize result variable. Our n is going to be the length of a, and in this case, we're going to set up an array. And so with that, we would then create a for loop, and we would pass n, and it's going to be the number of elements, right, for our array. And we are doing a running sum, so our result is going to be the index value added each time that it loops, and it's going to return result. So we have a running sum. Now, this is fine for a regular Python program, but if I want to use Numba, okay, I would just go ahead and add the decorator. So that means that I would have an import statement at the top. So you would say from Numba, that's our package or our library, import, and then you can name this whatever you want, right? In this case, we would use NB. In the prior example, you would see that it uses JIT. But JIT is just in time. It is an element of this particular library. So you would then decorate it. You would say, use the @ symbol, your identifier here, so nb.jit. And then you would define your function normally as you would in Python. So when it runs your program, right, it's going to see this, and it's going to refer to the library, which uses C compiler and LLVM to be able to break your function down to the low level. And that's how and apply the algorithm. So it's going to be able to optimize it through parallel processing, or, you can specify what you want also with the parameter here to be able to improve. So we would see a lot of the Python program that would be written traditionally, and we would then improve it using our Numba library. So here it tells you what happens in the background, right? The function is invoked for the first time. Once the library detects the argument that's passed, which is A, then your compile specialized version for the original functions is then going to be placed onto the LLVM. So it's going to use the Numba compiler instead of your normal interpreter. And so once it compiles it, you're still going to be able to see it on the shell side. but the process before the execution is that it needs to compile it. Okay. So this is what you would see. And you can integrate multiple functions, right? You can place a decorator on top of each of the function. In most of the example in our text, you would see that it's only used once, but in the documentation, you would see that they would be able, you can decorate each of the functions. Okay. So this is another example that you would see. In this case, we're using NumPy and Numba, right? And again, we would decorate that here. Okay. So the no Python mode is going to give you the best performance. That would be equivalent to if you decorated with the njit. Okay. So normally we would want to have at least this. Okay. No Python is true because we want this to be optimized with Numba. Okay. So that we would have the best performance. And if you want to test it, we all know how to use the time library, and you can also execute it. We will see that in some of the lab as well. Okay. So as we look through the example, we would then attempt number 3. Okay. So you're given this program, and this program is using NumPy, and this is a Python program. Okay. And we saw this in the prior week where we would use NumPy to initialize our array. And in this case, our ARR1 is the array container. And we would randomize 10 numbers using NumPy. Okay. And then we would print out our entire array. Then we have a function called double. And for this function, we're going to enumerate through. So when you use enumerate function, what that does is it is exactly how it sounds, right? It's going to iterate through the entire array. So it has a loop implementation with it. So here, what we're going to do is we are going to enumerate through the array 1 or ARR1. And we're going to take each of the value and we're going to multiply it by 2. Okay. So I have the index and the X because it's going to access each of the index in the array. An array is sequentially indexed from 0 through 9 for 10 elements. And it's going to take each of the value and it's going to multiply it by 2. The reason why I have 2 variables here is because I'm using an enumerate function within the for loop. So I want to make sure that it sees the index and it treats it as a value as part of the inner loop that's included in enumerate. And when we print, we want to print out each of the value and then we print out the array and its index. Okay. And then the double value. So we have this program, and what we want to do is we want to take this program and we want to apply Numba with it. Okay, so I'm going to show you. So here is the number 3 without Numba. Simply implement it with NumPy and to generate the array and double the value for each of the element in the array. So when we execute this, right, we're going to get something like this. So I have my array and I'm going to take each of the value, right, each of the array element and then multiply it by 2 to get X. Okay. And as I loop through, so by the time I get to the 10th element, which is index 9, right, I would have this. Now on the last line here, I have print double, which is my my function name and my array, right? And as you notice that it would give me none, because what I should do there is, in order to reprint it again, right, I would then have it to print for the array. Okay, so the original array value is here, right? As we double, we would show the double values. Any question regarding the original program? Okay, so how do I apply Numba with this? First, if you're using Tawny, right, or if you use another IDE, make sure that we add the package. So here I'm using Tawny, so I would go to Tools, Manage Package, and I would simply search for Numba. And VS Code is the same. You just search for the package and then you would install it. So once I see this, and now it has like the sub module with this, what you want is you want the entire package, okay, not the sub module. Because if you install the sub module, you might be missing some other module to be able to work. So make sure we just bring in the whole thing. And then you would see an install button. Since I already installed, it shows me upgrade or uninstall. So you would click the install button. And you notice that here it puts it in this location. And so I got to make sure that my Python path, right, is added to my system variable. Okay, otherwise all your site packages don't work. Now, if you're using Conda, right, it's going to put it in Python and then Anaconda and then Conda folder and site packages and other subfolders. So, you know, as long as your Anaconda is linked or set up in your system path, you should be okay. Okay, so make sure that you check your path. So once I have my Numba library installed, right, I would write my import statement. So I decided to use something similar to the textbook. So I would say from Numba, that's our package, import JIT. And you can call this NB, you can call it, you know, whatever you like. And since the original program has NumPy, I got to make sure that that's there. And then we have our array, and since that's global, so we got to place that on top above the function. We still going to print our array. The only difference between the original number and this is the import statement and our decorator. Okay, so whatever that you use here, you need to decorate that here. And if you want, you can say no Python is true like this. Okay, so if we look back, let me flip back over here for you to check. Okay, see how they use that here? So we can use it like this. And we can implement that here. Now, then we would have our function definition, just like the original program. So you can copy and paste that in. Now, if you copy and paste from Word over to, sorry, my mouse is acting up. Copying over to Word, from Word to your IDE, sometimes the symbols don't translate properly because of the encoding. So make sure if it throws error with syntax, make sure we check these symbols like the percentage and so on. Okay, especially the quotation mark. Sometimes Microsoft Word converted that a little different than your IDE application. Okay, so I added this above my function definition, and I added this at the top for my library. 2 lines added. Then now I'm going to go ahead and clear this. I'm going to run. getting trace back. Let me see if I need to, let me get rid of this. I tested this earlier and it should work fine. Okay. Yeah, it didn't like the, it didn't like the no Python is true. It won't suppress the warning and it can't pass that stage. So if you just use the decorator only, it should work. So, okay. So here it tells me that there's compilation for the path detected. There's some depreciate in for the compiler for JIT, but it's still going to be able to produce like what we expect. Okay, any questions regarding Numba in exercise 3? Okay. So as we proceed, we would see that there are specialized type or what they call the signatures attribute to be able to implement. So you can add in signature, okay? And that allows you to look at the specialized data type that you would use. So in the case where, remember that 2 weeks ago, we talked about how we can type, right, in NumPy, like a certain type, like float 64-bit or int 32-bit. Now, since we implement this, what we can do is we can also use signature to be able to handle these special types, okay? And it's supposed to compile this quickly, especially when we're handling different data type like this. Okay, so simply, if you add in the signatures, right, that comes out of the signature attribute from the module of the package, it should be able to handle that. Okay, and so this is an example of how they would implement this. Now, on the bottom, it tells you that you can explicitly compile the function by passing the signature as how it would be decorated for the function. So when we use the decorator, right, if we add in the attributes, what it would do is it would look at specific type that is defined in that function and as it compile it. So that means that each or individual signature would then be passed as a tuple. So it creates a container that would store the attribute of the type. And when it compile it, it would refer to that container to be able to obtain your data. Okay. And as you know, with C compiler, right, this gets pushed onto the stack, right? And as when it's called, it's going to be able to refer to that container, which is located in a memory location, and it will be able to compile that. Okay. So now the NB types module is going to be from your number, that's just one file in the package that would be used specifically to handle the signature attribute. Okay. And so what you see here is you would then also can use the decorator to be able to address specific or explicit AS type data type here. Okay. Now it says that in order to prevent some kind of error, and in this example, if it cannot find matching argument, so if you do it this way, that's correct. But if you do it this way, right, it's going to raise an error, because if it cannot find the file that would hold the signature attribute to handle the data type, it's going to give you a type error that it doesn't know what type that is. Okay, so if we pass it with just AS type float 32 like this, instead of using the Numba, right, module, then it's not going to be able to recognize it. Okay, so this is incorrect. This would be correct. And so to fix that, we would do this. Okay, and make sure that this is above your function definition. Any question? Okay, you can have multiple too. So in the case of if you have multiple signature for different data types, you can have 64-bit and 32-bit. You simply use a separator, and remember that each type you have to put them in individual, right, quotation like this for the definition for the type. So what this will do is going to create a signature for this type, which is float 64-bit, and then it's going to create another signature attribute for float 32-bit. And all of this is above your function definition. Okay. Any question? All right. So some of the things that we can implement with Numba is we already talked about using the decorator, but you can also use the JIT function, which can be decorated or generated JIT. Okay. So about a couple weeks ago, we talked about a function decorating another function, right? It's in a similar concept where you have a decorator. All that is it's gonna, right, tie your function to another function, right? And these functions belong to the libraries. And that's basically is gonna help you use the algorithm from the library that's defined in these functions to be able to improve your compile time or your runtime. Okay. So now the decorated function, it tells you here that it would be called with the number types in the argument, not the values, just the type. So you don't, for that, we would then have to specify the type as we would create the signature for these types. Okay, so let's talk about the next one in our assignment, which is number 4. When using signature attributes in Numba, how would you avoid error after explicitly declaring the data type? Okay, so we must use the same data type after the data type is declared using Numba signature attribute. You cannot have a mismatch. So in the example that you saw earlier, right, float 64 colon float 64. So you cannot have two types in the signature. It has to be matching. Okay. So coming back to this real quick, when you look at this example, see how this is used, float 64, and then you want to use a colon in the square bracket like this. These two have to be exact. We cannot have float 64 and float 64 now. On here, like this, right? For when you specify the float 32, now this is downcasting. So when on the downcasting, you got to be careful with this, because normally, even with the C compiler, Python would then dump everything to the larger container. So it's still gonna be 64. So it's gonna produce, decimal points or, values with precision points, but it's still gonna cast it up, not down, right? We talked about how we downcast. When we downcast, we should use the proper downcast function. So, but I normally recommend that we would keep the thing the same to avoid additional type error. So, and then we would use, right, the colon with the bracket like this as your type string to specify multiple signature. So if you have many signature, what that will do is it's going to create a container or an array of signature, and it's going to use that to broadcast the attributes for the signature. Okay. And then as we saw when we talked about JIT and generated JIT decorator, for number 5, when should you use generated JIT decorator compared to JIT decorator, right? You would use the generated JIT in functions to implement different input types to be able to have a selective specialization in the compile time to avoid reduction of speed or without jeopardizing the runtime speed. So if you're using JIT decorator only, and if you have different input types, what will happen is it's going to slow down. Now, if you have a mixed input types, then we would use generated JIT, okay? And it was created for this specific reason. Any question? Okay, you can find the answer for 4 and 5 on our notes under specialized type. Okay, so you can find that on page 4, 5, and going into 6 right here. Okay. All right, so the next part we're going to talk is about modes. So it tells you here that when Numba cannot infer for variable types, it would still compile. What it does is it's going to go and refer back to the interpreter, okay, for things that cannot be supported. So you would see some warning coming through, and it's going to tell you that certain things is not going to be supported by Numba. And so that means that Numba actually operates in these modes. One is going to be an object mode, where it's going to create, right, object as it compile. If it can't do that, if it's not able to infer the variable types, then it's going to go to the interpreter or the native mode. Okay, so there are 2 modes. The object mode is when it's able to compile, right, and use LLVM. So if it cannot infer the variable types, then it would go to your native mode, which reverts back to your interpreter or your Python interpreter. And this is going to be generally slower than this, okay? So that means that it has to look at the type, right, when the function is called. As you know that as you compile, right, all your variable, all your container, your array get pushed onto the stack, which is a location in memory that is used to be able to execute your function. Okay, so for Numba, the way it's designed is that they implement a function called inspect type. So it needs to check the type to be able to see which mode can be used. If it cannot infer the container or the types, then it's going to revert to the native mode. If it's able to build, right, with the known types or see the signature of the type, then it's going to use the object mode. Okay, so this whole section talks about that. And so that means that we can use the inspect type method or function to be able to set up, right, for our program to compile using Numba. So you would see this in the next part of our exercise. When you look at the output, it's going to show you something like this, right? It's going to show you like your global variable, the function, how it used that variable in the function. So on the native mode, in this case, it tells you that it does have limited support for string operations. So when you're using string type, okay, it would need to have the inspection. So that means that we need to add in the inspect type functions to be able to access the string signature. Because string is a container, right? It's a group of characters. So therefore, we need to look at and not break it down to the group of characters. So it needs to be seeing it as an entire container. Okay, so it doesn't have the broadcast functionality for string to treat it as individual characters inside an array of characters. Okay, so when you build it with like this, when you see the output, it's going to tell you for each line how the string is then referred to the interpreter as object. Because in C, string is a string object. Okay. Any question? So it would show your Py generic type. So it convert that to Py object. Okay, so let's take a look at the next one, number 6. It asks you, when is object mode used? Okay. And we would say that when the types cannot be determined or when certain operations are not supported by Numba. Okay. So if it cannot determine the type or it cannot utilize a certain operation or it's not supported certain operation in Numba, it would then use the object mode. Hold on 1 second. Let me check here real quick. That's right. Any question? Okay, so now we're going to implement inspect type to our prior exercise. Hold on, let me change my USB port real quick. Hopefully that won't go for. Okay. So for number 7, we're going to add in the inspect type to our exercise 3. Okay. So here's my exercise 3. We saw that we added this, right? And we added the decorator. Now we're going to do the inspect type. So the only change that we would have is we are going to do it at the function call. Here's my function definition. I call it double, right? I should use a better name. Actually, I'm just going to use a better name. Okay. I would take the number 3. Okay, I still have the decorator. I still have Numba import statement the same. The one line that I need to add is on the bottom. So we call the function when we print here. So we need to add another one. So for Python, right, main exists, but you can use if namespace is main. Otherwise, if you place it on the bottom, it's going to treat it like it's main and it's going to call. So I would then use my function and I would add inspect type method. Okay. So you would do the inspect type like this. Okay. Let me clear. So you saw the prior output. Now we're going to run this. Okay. Slightly different than the last. You're still going to get the output with the double, right? We multiply it by 2. But here what you would see is just like what you've seen in the notes or the text, it's going to give you the breakdown where your container, right, type is actually assessed throughout when it compiled. So it tells you the line, right, line 11. So as it access the type, okay, for my variable to loop. And you would see, for those of you who are familiar with low-level programming like assembly, you would see some of the details in that, right? Like how it jumps. Because for the loop, when it gets to the one loop, right, it's need to jump back to the beginning for the call again. So you would see the label, right, which is our function name, and then it's going to jump back to that. Okay, so if you took CIS11, when you look through this, you should see it somewhat on the details with the low level. And then how the type is used and how it's used in the function and return. And then the operation. So anytime that your data is accessed, right, it needs to inspect the type of your data. So it tells you the line. And then my decorator and so on. So you're going to get a lot more output, right, in detail. So it's very verbose, where it will give you the inspection of your data type in each section or line, or sometimes the same thing over again. Okay, any question? And as it add things and remove things from the stack, you also see that too. Okay. Okay. So all I need to do for number 7 is to add this line to my number 3, run it, take a screenshot for your assignment submission. All right. Any question? I see a chat. So what if it says double val is not defined? So if I change it here, I gotta make sure that I change it here and here, right? If you have it double right here, then all your function call needs to be the same. So if you change it here and here, gotta make sure that your function definition is changed as well. So for number 3, you have it as double, right? Make sure that it's double throughout. Like this. So however you define your function call has to be exactly the same name. Okay, I hope that helps. So in this class, you're going to see a lot of reference things that you might have learned in CIS 5, 17A, and 17C, right? And 30A or CIS30E. So we go back to some of the concept, but then this class, because we're using C library, there's a lot of reference for C as well. Any question? Okay. All right. So the author shows you how you can implement the time to look at, the execution or the runtime for your function. Okay, so we saw how we used timeit module before. Okay, so let's talk about Numba and NumPy. You know that the author who wrote NumPy, right, also wrote Numba. We saw that at the beginning. And we would use Numba to increase the performance in general, but especially when you work with arrays, okay, for NumPy. That was the real purpose, I think, is to be able to operate numerical values at its best performance. So in Numba, there's a thing called universal function. This is a specialized function that is used for arrays in different sizes and shapes. We learned when we talked about NumPy in the prior weeks that you can shape your array multiple dimensions, right? We can create shapes. We would be able to do scalar, right? To when we're handling different shapes across multiple arrays using broadcast rules. So to streamline this and improve the performance using another library in concurrent with NumPy, we can use a thing called universal functions. Okay. And universal function is really designed to handle arrays with different size and shape. So meaning different dimensions. And it would take multiple arguments to broadcast, because when you're working with, let's say, 2 different arrays that have different dimensions, you have to scalar, right? It's going to take the smaller one and it's going to scale out to be equivalent. So that way it can broadcast the same. Okay. So in the universal function, we can use something like sum or difference. Now, in the next part, it tells you that when you define and implement scalar version, you can use something called vectorized function. This will help with the broadcast feature to handle different sizes for your array. So the example is like this. So if we have just a Python program using NumPy, we say import NumPy, and we define our function, cantor. Okay. Then we would take the value, we multiply it by 0.5. So after we add A and B, we're going to multiply it by 0.5, and then we're going to multiply it by A plus B plus 1, and then plus the B. So it needs to operate, right, based on priority. So in this case, what we can do is we can implement the universal function, or ufunc. Okay. And we can apply the vectorized function. So vectorized decorator is a universal function. So you simply would then use a decorator. So as I import NumPy as NP, I would say np.vectorize as my decorator and place it above my function definition. Okay. And at the end, I simply call it, because once I define it here, right, I can use it to return the value. So here I would do cantor, which is my function. So here's the call, right? And I want to take all of the return value and append it into an array and shape it. Okay, so it needs to take the value that's returned, append it, but during that process, we would then need to scale and broadcast. So because we need to shape it. Okay. Any question? Okay. So it tells you here that with this, okay, when you use a universal function, with the implementation of C, which is what we see with Numba, right? It is better than using what you would see directly with just C or Python. Last week, we talked about Python using C compiler to build your Python program, right? We just got to define our type in CDEF and all of that good stuff. This week, what we can see is we can implement another option is to use Numba, right? Which gives you convenience because you simply use a function to decorate another function by bringing in that package. That simplified the process. You don't have to do the setup.py and then write things in Pyrex and then convert it over like Python. Python require additional steps, right? But using Numba, right, we simply bring in the module and be able to build it directly. Okay, so, you know, this is definitely more convenient. And so when the author tested this, you can see in the Python, right, the output for the loops, that's the time. Using Numba, that's the time. Okay. And then using NumPy only, that's the time. So compare these three runtime, what you see is Numba beats the rest of them. Okay. Any question? Okay. There's so many different type of functions in this one that you would need to remember. Okay, so we talk about ufunc. Now we're going to talk about gufunc, or generalized universal function. So this is another form of universal functions. Okay. And this was implemented because there is a limitation with universal functions. So they came up with generalized universal function. This is an extension of ufunc. So when you deal with arrays that's multidimensional or matrix, right? Like matrix multiplication, array, mathematical operations, things like that, this will come in handy. So the example that you see here is we randomize for A, right? This is the dimension of our A array, 3 by 3. This is B, 3 by 3, contain random values. They are both containers, okay? And then C, we implemented a function called matmul, okay? This is to handle matrix multiplication, matmul. So we want to take A multiplied by B. So instead of looping through A, take each of the element, then loop through B and multiply them, right? We can do a nested for loop to be able to operate the multiplication for our matrix, right? Which we can treat as a 3 by 3 shaped array each, okay? That will be okay, but it won't be optimized. So we can implement matmul to multiply A and B matrices, okay, and then shape it, or use shape here to show that the output is going to be 3 by 3. So you can multiply the matrix by using matmul, which is a GU func, generalized universal function. It's an extension of your universal function. So it streamlined the process for you, okay? And again, we can handle things like 10 by 3 by 3, 10 by 3 by 3. So multiply these matrices, right? We're using matmul, we can output. Now, earlier we mentioned that yes, we can use different shapes, right? The last two examples, you see that they're exactly the same. But on page 12, you would see that we have A, one different dimension than B. So we would have 10 by 3 by 3. We need to multiply with B, which is 3 by 3. So the shape is different here, right? So in the earlier chapter, when we talk about NumPy, when it broadcasts, the broadcast rule for arrays, it's going to take the smaller shape one and it's going to scale out to be equivalent to this. So that way it can multiply the number, right, inside the matrix. So you would simply define your array or your matrix. Then you would then set up your matmul function. So we simply pass A and B. And so it's going to take B and it's going to scale it out to be equivalent to the same shape. And it's going to operate the multiplication. So then it's going to output, of course, it's going to scale out to 10 by 3 by 3. So the shape, the outcome shape is going to be 10 by 3 by 3. Okay. Okay. So just like the universal function, when you use the GU func, we would use a GU vectorized decorator, right? Earlier we said that for the universal function, we use vectorized. For the GU func, we would use GU vectorized. And this, an example of this is that we can implement it for Euclidean distance, for the array, for functions. So in research or in the case where if you have analysis that would require more advanced computation, right? These things would come in handy if you know how to apply these. So for the GU func, when we use the decorator, we need to use 2 arguments. We need to pass 2 arguments. Okay. We would have input and output. So we would do 2 arrays. So the example is that we can use the 2 1D arrays for the input and the scalar as the output. And we will look at the example now. Okay. So here's how you can vectorize. You got the type, right? Remember we talked about the signature earlier. And then you would then have the shape. And this is an example for Euclidean distance. So your input and your out. Okay, any question? So in the last, 10-15 minutes, we talked about universal function and generalized universal functions, how it's used. And when we implement universal function, we use vectorize. When we implement generalized universal function, we use GU vectorize. Okay. Okay. So let's work on number 8. So you're given the below function, right? Test u func xy. And we would use numpy to define the universal function and numpy vectorize to enhance the function decorator. Okay, so you would take this function and we would apply the universal function to it. Okay. So as we just talked about that, here's number 8. So to implement universal function, you need to import numpy or num here. So I would say import numpy as num. And since I'm using universal function, I need to decorate it with vectorize. So whatever I use here, that's going to go into my decorator with vectorize. So I would say, right, at, which is the decorator symbol, my identifier for my import, from my import statement, and then vectorize. And then I would take what's given to me in my assignment. So I would define my function def for defining my function. That's the keyword. And my function name, I'm going to pass x and y. My return is going to be integers. So I parse it into int. I would take 0.7, multiply it by x plus y times x plus y plus 2 plus y. Very similar to your example, right? So the return value from here needs to append into an array. And as it does that, we have to broadcast the value because we have to shape our array. So therefore, we need to vectorize it. So after I define my function, then I would call it in the print method. So here is my function call, right? Same exact name. And I need to put it into an array. That's the whole purpose of using NumPy. So I would say num array, and I would give it a shape, 6, 8, and 5. Okay, let me clear this. So this is how you can take a function definition and apply universal function or ufunc with it. We can decorate our function with the universal function. Now, in the regular Python program, right, I can define my function. Now, as I return, I would want to put that into a list. So you need to use an append, and I would append each of the value into a list. and then loop through that list to print, or print that list after I append, right? But using NumPy, what we can do is we can decorate it. So it saves us maybe a few lines of code, but it's also going to optimize your performance. Okay, so NumPy goes a long way, especially when we're handling numerical operations. Okay, so let's run this. And it's done. Okay. And because we parse this into integer, so I took the 6th and the 8th, right, index. And then when you call this, you gotta pass the value so that way it can output some kind of value for you. Okay, so it took those value and put them in a container for me and show it. Okay. Any question? So in this exercise, we apply universal function and we decorate it with vectorize for our function definition. And you can play with this. You can test it with generalized universal function using matrices. And so now you know how to use it, right? You would be able to apply this for your assignments and your future projects. Any question for question 8 or exercise 8? All right. So the next part is going to be Pypy. And this is the replacement interpreter to look at your code and optimize on the slow loops. We can implement Pypy. And similar to what you've seen with Numba, we would use JIT compiler just in time. Okay. Because compilation perform in runtime rather than running the code after it's compiled. So when you look at C++ program, right, we compile the program, then it executes. Just in time, it runs as it compiles. So it shaves off a little bit of time for you. Okay. So these packages that we're working on today with Numba and Pypy, it uses JIT, and JIT would give you a better runtime because, right, it tells you here the compilation is performed at runtime rather than before running the code. Because in general, when you look at C compilation, we would compile and then run the code. Now, for JIT, it is performed at runtime. So we would declare the inputs for the type. It's the example shown in the previous with A and B like this. So you have randomized container or container that contain randomized values for A and the same thing for B. And then we would take A, subtract B, then have it operate here and then do the sum of the axis. So the author chose this to time on how it would produce the values based on regular mathematical operations and Euclidean distance. And as you can see, right, we would see improvement in time for both parts. So, but Numba doesn't always have everything that would be optimized. So in the next part, it talks about for optimization of Python objects. It doesn't support that. Okay. It would need to define the class that's used in the native mode so that way it can compile quickly. So how you create your data structure is important when you're working with Numba and NumPy. Okay. Now, we saw that we can implement for fast array handling, okay, with Numba and NumPy. For the linked list, can it be implemented in value for the extended list? So the way that we work with linked lists, and linked list is the same across like C or Python, like this, right? We would have a node connecting to another node. So you would have a head, right? And you will have a tail. In this, basically, we would identify it as a head. It's going to link to the next node, and that next node is going to link to the next node or the tail, right? In this case, we only have 3 nodes, so it can go on a lot longer. But at the end, you are not going to have any link. That's going to be your tail. So what you're doing is you're building a data structure where you would have a container that's linked to another container, that's linked to another container, and that last container is going to be the end. Now, on the doubly linked list, when you learn this in C++ or another class, this last node is going to link back to the beginning. So it's going to point back to the beginning. So normally in a linked list, we would see that we would have container that's pointing, right? So it needs to link to the next one. So we would use a pointer to go to the next node and then the next node. And on this one, right, it's going to end. So there's no more pointing. But on a doubly linked list, on the last node, right, it's going to come back to the head node. Okay. So in simply writing a singly linked list like this with node to node to node, you would define it this way. You would have a class, right? In that class, you would then have a constructor, and you would then define your member variable. Okay. And so what they did was here we added a second class called linked list, right? We would then define or initialize or instantiate the members inside that class. Then we would also define the function so that way it would be able to link from one node to the next. Okay. And these two classes would work together. One class is going to be holding mostly your data. The next class is going to be containing, right, the operation or the mechanism of how each node is going to link. So it needs to utilize this class in order to build out the entire structure. Okay. Any question? So part of the linked list, as you can see how we would be able to get one node to the next, right? You got the head. You would type it as the other class, right? Node. Then you would go to the next and then the next. And then to really print out the value, we would then have a function and we would implement the loop to do that. And that's how you can implement singly linked lists in Python. So in C or C++, right, for the C++ side, we would then use a pointer to be able to point. And that's a little bit different where you would have a pointer for each node, and then it's going to point to the next. So that way we don't have to create container in every single node. Okay. So when it prints, it's going to show you how it's going to add, right? So it's going to add the value to the first, the second, the third, and then it's going to show. So it's last in, first out. So the last one comes in is 3. So 3 is going to show first when you print. Then the next is 2, right? Because last value comes in is 3. So you're going to have 3 to show first because that's going to get access first. It's on top of the stack. And then it's going to access 2. And then it's going to access 1. And as it does that, right, what you would see is, because sequentially, when we look at this, coming back to the top here, we assume that, so 1 is going to actually get pushed in first, and then the second and the third. So the tail node is going to be first. Okay, so when you push, it's going to be in reverse because it's going to access the head node first to print, because we want this in the front, so it's going to get pushed last. It's like stacking plates, right? So if you have 3 color plates, right? Red, green, and blue. If you want to get the blue plate first, it's going to get stacked last. So we want this head node first, so it's going to get added to the stack last. Okay. And that's what you see here when it prints. Any question? Okay, so this is a little bit more advanced on the data structure side, right? Some might be familiar with this already as you took other data structure course or programming course. It's heavy addressed in CIS30E for C++. And then I talk about this in assembly toward the end when we talk about stack at low level. So for CIS11. Okay, let's, we have 30 minutes left. So let's move on with the assignment as we talked about your linked list. Okay, so for 9, we're going to implement generalized universal function, right? We are going to use matmul, matrix multiplication, to multiply 2 arrays that contain 5 matrices in the shape of 3 by 3, very similar to your example. So I'll show you how to implement this. Here is 9. It's really easy. Let me clear. So I have installed NumPy, right? For those of you who missed that chapter, make sure that we add that package, just like how we did with Numba. And so we would then import NumPy. We would define our array that contain matrices, right? So we have X array, and we are going to randomize it. It is 3 by 3. Right? The assignment said, yeah, 5 matrices. So it is containing 5 matrices, and it is 3 by 3. Same thing for Y, right? We want to keep the same, so you don't have to GU vectorize it. But if you have it different, we can scalar it. Okay, so it's exactly the same. So it's going to generate random numbers and put them in the shape. Then I have Z. Z is going to be my container for the result of the multiplication of my matrices, right? For the array of X and Y. I want to print out the content of Z after it multiply, and I want to print out the shape. And we're going to run Okay, so it gives me Z, and it gives me the shape, which is 5 by 3 by 3 because it's the same shape. And even if you scalar it out with different shape, it would go to the larger scale shape. Okay. And that's how you can implement generalized universal function with MapMold. Actually, we didn't write a function for this. You can implement a function for this. Let me look at that again. Oh, yeah, it only requires MapMold. So you can define a function and then put these like how it would be in your, let me fix this. Okay, hold on. Sorry. Let me come back to here to see if they did. Yeah, we're not vectorizing, so we don't have to decorate it. So we're fine. Okay. But if you want to decorate it, you would then, if you want to implement vectorize in the case of its different shape, then you would define a function and then decorate it, and then you can apply MapMold within it. So it should still be the same. But you're okay doing it this way. Any question? Okay, so this was 9. It's fairly easy. We're just using NumPy, and we did matrix multiplication for the same shape for 2 containers. And we print its content and its shape, which is 5 by 3 by 3. Okay. Okay. Let's go to the next one. Okay, so we did 9. Screenshot that for assignment submission. For number 10, when should you use number JIT class? So we would use JIT class when we're implementing data structure like linked list, using objects to deliver fast performance. Okay, any question? For 11, how do we install PyPy? Right, it's always good to look at their documentation, but you would go to pypy.org/download. You would select the precompiled library for your operating system. So if you're using Windows, you would select Windows. If you're using Linux, so you select the binary files that would work for your OS. Then you would extract or decompress the file using the third-party tool, and use third-party tool to install. So I put here that you need to look at the documentation if you're using PyPy. Okay, so once we download, we gotta extract. Now, if you're using Linux terminal or Mac terminal, right, look at the documentation first. It should show you how you can use tar to pull you can download using curl and then use tar to extract in command line and be able to install. Okay. So everything we can do on the graphical user interface, we can do in command line. Any question? Okay, just a little bit left to go. So now we are going to talk about we talked about a little bit about PyPy. And JIT class. And then it goes further and it talks about defer type and also for your optional decorator in that. And we talked about Numba limitations and then PyPy. So PyPy documentation is linked there. You can also find additional information there. 2 separate pages, so I put that there for you. Oh, note that PyPy is not in C, it is R Python. Okay. And so it is a little different than the other packages that we talked about. R Python means restricted Python, so it's implementing like the compiler development a little different. Okay. But you're also able to access JIT compilation, or it uses JIT compiler. Okay. And then installation, I put down the step for you here. So in Linux, you would use tarball or tar command. And then in Windows, to decompress, you just download the folder to Visual Studio and then use the run library installer. For Mac OS, you would download the package and install the package. It will be like the PKG file. And then it uses the Linux, for the Linux virtual environment, this is how you would use it with virtual environment. All right. Let's see. And then there's some example with perf or pref. This is used for timing along with the time it module. So you can do that for benchmarking. So I put some example for you there. Okay. All right. The last one is on Nukta or NUITKA, right? Nukta is a program that is in Python and compiled to C. Okay. So it is performance over C Python, similar to what you see with Python. It is different than Python though, okay, where it doesn't extend. Python is an extension where Nukta is not an extension. You can visit the website. So these are additional projects that you see to improve performance. So you can use, right, additional package like this or tools. Okay. Python is a different interpreter. It also uses JIT compiler. So all of these package and tool that you see in the industry now is using JIT compiler. Okay. It is different than PyPy, and it is doing one method at a time in JIT. And just in time, you know that it runs as it compiles, right? So instead of one method at a time, it's going to be close to what you see with Numba, where it uses the LLVM, low-level virtual machine. This is still in development, so you don't see it full-fledged yet. I last checked. They only support version 2 of Python. I haven't followed up with it, but I will look to see if they have development for version 3 for Python. So this would work with the older Python, which is no longer supported. But this is an option if you're using version 2 Python. Okay. And on this one, it is different than Python, but it would use C Python. And so that would be another option for some performance improvement. Okay, so Numba, PyPy, Nukta, and PyStomp. So let's do number 12. And you can pull the answer from that section. So describe other compiler projects that would help your improvement in performance for Python. So we would say Nukta is a good replacement for Python interpreter. It compiles every language construct that would be relevant to C Python. And it would translate Python into C program. And it's linked against libPython to execute exactly like C Python. It is extremely compatible. Okay. Where PyStomp is a fork of C Python 3.88 with additional optimization for performance. It is targeted for large real-world application like web serving, where it would deliver 30% speed up in development. And later on, we would go through a chapter where we will calculate the speed up, especially when we're working with concurrent or parallel program. So some cases you would see like an 80% speed up, but when you're using this package, when they benchmark it, they do see for more complex advanced application, there's about 30% speed up. So it's moderate. Okay, so option for things that needs to be real time or close to real time, we would want to consider compilers and package and tools, or even frameworks that will help in performance. Okay, any question? All right, so I did activate, I believe, hold on 1 second, I'll flip back to that. A quiz for this week, so don't forget to do that by Sunday. I recommend that you go through the review game. You can get extra credit if you screenshot your score and submit it. Okay, and extra credit is added at the end of the course where I would see the area that you need the points. I would put them in there. Okay, and I would add the comments for that. So we are going to cover chapter 1 through 4 in the quiz. The quiz is multiple choice and you have 3 tries. So if you take it a couple of times, if you want the 3rd try to be a higher score, so whichever time that have the highest score is going to be recorded, and it's 40 points. Your extra credit is going to be 20 points. It's not allocated to anything yet. Okay. So these 2 needs to be by Sunday. I do not allow late credit for extra credit, only because it's fair and I need to release the price. So if you have the highest score in the class, I will send you an Amazon gift card of $25. Okay. Now quizzes, if you're familiar with quizzes, the faster you answer, the higher you score, right? But you have to answer right, of course. So, and you have to attempt in quizzes. We are going to work on Numba and PyPy in Linux for Lab 6. Linux is the best for Python and using these things because, you know, it works with the libraries fairly well. It's really made for that, right? It's made by developer for developers. So, you know, using the virtual machine is going to be important for the, you know, throughout this course. So if you have the virtual machine, we will continue to use it. If your virtual machine has limited storage, I would encourage you to, you know, archive your file, like you can throw it onto the cloud and then delete them. Okay. When you work on the project, you can look at them again. I will give you options in how you want to write your program with best performance. And you need to show me how you can improve performance in your project. Okay, so our project is going to be Python program, but you can implement different modules and packages to get more higher performance as you test your program. Okay, so for our lab, that's what we're going to do on Thursday. And I posted this already, so we are going to go through and do the PyPy. If I see that needs to be any kind of edit, I will let you know, but we are going to do a sort algorithm, okay? And then we are going to, actually two sort algorithm, a bubble sort and a selection sort. So I'll show you how you can do this using the libraries that we talked about this week. Okay, but don't forget about the quiz and the quiz review. Okay, let me bring back the assignments in case you need this. I'm going to go ahead and stop recording. I'll stick around for questions if you have questions, or if you have difficulty with your Jupyter, we can hang out and talk and see if I can help you virtually. Okay. All right.